Hello and welcome to our next lecture on mass, volume, and density. So, we've been talking about identifying minerals, and it's important now that we learn a couple of other physical science concepts so that we can better identify minerals, but not just minerals, everything around us really in the physical world. So let's see how we, as scientists, measure and really make sense of the world around us. So I've talked about this a little bit, and definitely don't write this all down, okay? Because this is kind of just a concept that you need to get burned into your brain. So what is matter? I've been talking a lot about matter, and matter is the foundation of physical science. So in order to describe this, we use the kinetic molecular theory. Okay, and it sounds really intense. It's really not. It's really just, we think of matter as little tiny balls that's what makes it matter. So these are like your little atoms, and they're bouncing around everywhere. And so when they get energy, they do different things. So if they have low energy, and they're highly organized, they form what we see as solids. So that's what we see as minerals, right, in a crystalline pattern. Sorry, I'm kind of losing my voice a little bit. If it's a liquid, you can see they're a little bit farther apart, and they're not as organized, and they have a little bit more energy. They're moving around a little bit more. And then, as we know, if you guys have ever boiled water and it turns to steam, that takes a lot of energy. So that gets the molecules moving so fast that they're flying around everywhere, and as soon as they can, they separate as much as they can. This is why gases fill up entire rooms, right? So you could take something that was in liquid form, say like an essential oil, and you can heat it up and it'll expand into the entire room. So this is what matter is. So this is for any atom of any element. This is kind of how we look at it. And so just so you know, this is the kinetic molecular theory, but it turns out that when you get deeper into like quantum mechanics, which we don't need to know about, some of these theories kind of break down a little bit, but again, that's way outside the scope of this class. So I'm going to keep moving on. All right, so definitely don't write all this down. In fact, don't really write any of it down except maybe the first line, because I'm going to tell you what units you need to know. I just want to make sure you're familiar with what units are. And units can be very, very helpful, especially when if we do any kind of math. And this class is low on the math, but if you do take like a physics or a chemistry in the future, units are going to be something you really need to know. So let's just make sense of them. There are different units for different physical properties of matter. So that makes sense. What are we trying to describe? Are we trying to describe how much matter something has? Are we trying to decide how much space it takes up? Are we trying to decide how fast it's moving? Those are all different physical properties. And so in science, we try to label them and keep track of them. So the first bullet point, there are different units used for the same physical property, but using a different tool. So this kind of confuses people, and you're going to see this today, that for something called volume, we can use milliliters, or we can use centimeters cubed. And again, you don't need to write all this down, because I'll show you this in the future slides. But basically, depending on what the thing is that we're measuring the volume of, the amount of space it takes up, then we need to use different units. The next bullet point, there are different units for different physical properties for different cultures and societies. So you guys know this. That might sound like a lot, but you guys know that we use the mile, while some countries use, in fact, most countries use kilometers, right? And in fact, in the United States, we kind of switch back and forth. In this class, we will use the SI units of measurement, which is like the international science units. So we tend to stay away from pounds, miles, things you might use in your day-to-day life, and you got to get used to using like kilometers, grams, etc. So within the same units, there are different subtypes used depending on how large or small. So if we're looking at something really, really large and heavy, we're going to use kilograms. And if we're looking at something really tiny, we may use grams or even milligrams, you might have heard of. And if you ever take a chemistry or physics class, you're going to need to know exactly how to calculate those. This class, we don't deal too much with conversions. And that leads me to my last point. So in those other kinds of classes where we do a lot more math, they can be related through equations. So we call those conversions. So we need to convert from grams, or let's say you go to Europe, so you need to convert from kilometers to miles, so you know how fast you're going, because you don't know what kilometers per hour is. You know what miles per hour is. So there's an equation that'll convert that for you. And that's the same for most units. If you've ever had to bake something and it's given you a unit that you're not sure of, like tablespoons, and you want to go to, let's say, milliliters, you can do that as well. In fact, I just had to do that yesterday because my daughter needed some medicine, and the directions were in teaspoons, and all I had was a syringe that measured in milliliters. So those are the different ways we use units, and I'm taking a little bit longer on this because we are covering some key points here. Again, if you ever take like another physical science class, you'll learn more about how we convert those, but in this class we'll stick to the basics. So now that you know what units are, let's take a look at what mass is. And this is really pretty simple. So it's the amount of matter an object has. So if we want to measure the physical property of matter, then we're going to use the unit of grams or kilograms. And again, this is the standard international unit. And so that's what we stick to. If it's really large, we use kilograms, like we already said. And if it's smaller, like the minerals you guys have been dealing with, we'll use grams. And so this is like smaller, but it's all relative. It depends on what you're dealing with. So what tool do we use to find mass? What do we call this right here? We call it a scale. Okay, and we have a couple in this class. They're up in the cabinets, and we will be using them, and I'll show you how to use them. In fact, next week. They used to use something called a triple beam balance scale that looked kind of like this, right? And you put some weight on this side, and you try to balance it out with a known weight on that side, or sorry, I should say mass, and then you try to balance it out till it's directly in the middle. So technology has evolved. We use electronic scales now. And I'll show you how to use those later on. But that is what mass is, okay? So everything has mass in the universe, essentially. If you can touch it, it has mass. So when we measure how much mass something has, but there is a key point we'll talk about in a second about mass where it gets a little confusing. And this is that key point I was kind of talking about. So mass is actually different than weight. When you put something on a scale, it can give you a weight, or the scale will convert it to mass based on where you are. Since we all live on the planet Earth, the scale just automatically takes your weight and calculates it based on the force of gravity pulling down on you. And so this is a really important concept that I will quiz you on. So weight is actually a unit of force. And hang on one second, I gotta clear that. So weight is a unit of force, but you may be used to maybe saying mass and weight is the same thing, so now you know not to. So you may be used to using pounds, but in science, the force we actually use is newtons. So if you ever take physics, you're gonna learn more about newtons. We don't talk too much about newtons in here, but pounds are not the same as, say, grams. They're different. Grams measure mass, which is the amount of matter, and that mass that we measure in grams is the same anywhere in the universe, because when you go somewhere else in the universe, you're still taking all of that matter with you. What might change is where you're standing on. You can see here your weight on the moon might be different than your weight on Earth because there's a different gravitational force pulling down on you, and so that weight is the force we're using. So we don't deal with pounds, we deal with grams, and those are different because grams are relating to how much matter you have. So make sure you guys understand that major difference. Weight is based on gravitational pull. So you might want to write some of this down. Maybe not, try to make it more concise, but as long as you understand the concept, they're not the same. Okay, so what is volume? So volume is very simple. It's the quantity of space an object occupies. So the unit of measurement we will see are, like I said before, depending on how we're measuring it, you will use either milliliters or centimeters cubed. So the question is, what do you use when? And I'll let you think about that for a second. So we see these two tools here. When would you use that versus maybe a ruler, right? Because rulers have centimeters on them. And if you've ever used something, this is called a graduated cylinder here. And if you've ever used something like that, it has milliliters on it. Kind of like when I was talking about the syringe I was using. Milliliters are for fluids. And rulers can be for solid objects, and we'll talk a little bit more about that on the next slide, because you might not want to use a ruler for all solid objects. But if you can measure it centimeters, and because it's not a liquid, it's a solid, then you can use centimeters cubed. But again, we'll talk about that in a second. So those are the tools we can use. You can also use, so graduated cylinders, you'll see we'll use one of these in our class, and I'll show you how to use those in a couple slides. But basically, those are the most accurate. You can also use beakers or anything that has that measurement on it that holds a liquid. But let's keep moving. So let's take a really quick second to look at a conceptual question, and I will turn off that ringer that keeps going on. Which do you think would have the greater volume? Which of these two? 1 kilogram of feathers or 1 kilogram of rocks? Take a minute to think about it. And then think about which would have the greater mass. So hopefully you realize that this is kind of it's not meant to be a trick question. It's meant to make sure you guys understand the concept. So they both have equal mass, right? So the mass is equal. 1 kilogram and 1 kilogram. But what will change is the volume. You're obviously going to need a way bigger volume of feathers than you will of rocks to get to the same amount. So you guys hopefully inherently know that rocks are have much more mass in them. You know this because they feel heavier. A lesser amount will feel heavier. Whereas it'll take a lot of feathers to get up to a kilogram. You would need to take up a lot more space, correct? So that's why the feathers will have more volume, but if they're both at 1 kilogram, then they will both have the same mass. So that's an important conceptual question to understand. So this slide, we can actually cut through really quick, because if this was a more advanced class, like a more advanced math class, like some of you may take someday, like trigonometry or pre-calc, or even in calculus, you start to use some of these equations more often, maybe even in algebra. We will not use these equations, but we may use this one. And this is where the centimeters cubed comes from. So if I give you a ruler that measures centimeters and I want to find the volume, you're going to measure that. Let's say it's a square object. So we will only use rulers in this class to measure cubic or square solid objects. And that's because we can measure the length, width, and height. And then when we multiply all that together, each of those are measured in centimeters, right? That's the unit for each measurement. So what happens when you multiply centimeters times centimeters times centimeters? Well, if you know anything about math, you get centimeters cubed. So that's what gives us our volume. So that's why volume can be centimeters cubed and it can be milliliters. So if we, in this class, if we have a cube or something that's kind of square, then we can use a ruler to find its volume pretty quickly by using this quick equation. You can do it with other things that you see here, but we're not going to. I'm not going to make you do that in this class. So let's say we have an irregular shaped object and it's solid. So I should say, and it's solid. What do? Can't use a ruler. So what are we going to do? Well, there's this thing called the volume water displacement method. And it's really simple. You fill up something with water, you measure what volume that water's at, then you put the thing in, you measure it with the volume of the object in it. So let's say you take a graduated cylinder, place the object in it, you measure where the volume is at, and then you take the object out, and then you measure where the volume was at before and subtract it, so you get the difference. So what you get is that then that will actually give you the volume of that object in milliliters, because we're measuring how much it changed the water. And I can give you an example of this on the next slide if you're kind of confused. But obviously, don't forget to read the graduated cylinder from the bottom of the meniscus. I'll show you a couple slides. First of all, let's look at how this displacement works. So if we have some kind of mineral or object that we want to measure and it's irregular, we can't use a ruler, then what we'll do is we'll take a known volume of water, and it looks like that's at 7. Then we'll place it in, and you guys inherently know the volume of the water will go up. And the difference, so now it's at 9, so 9 minus 7 equals 2. That would be 2 milliliters in this case. So that means that this rock took up 2 milliliters of space. So the volume is 2 milliliters. And we will be using that method in this class. So really quick, you guys heard about the meniscus. What is a meniscus? Some of you guys have probably heard like, I tore my meniscus, or you've heard of somebody tearing their meniscus. Different kind of meniscus. So a meniscus that I'm talking about is how water, and we're going to learn about this later on, has this special property where it kind of likes to stick on the sides of things, and you've probably noticed this before. Water doesn't always just roll off. It kind of drips and forms beads. So water is, in its own way, kind of sticky. And so what it does when it's in this graduated cylinder, this narrow graduated cylinder, is part of it kind of sticks up on the walls. And you guys will see this when it's in a graduated cylinder. So the question is, where do we measure it? And the answer is you always measure it at the bottom part of the meniscus. Okay, so at this part, the bottom. So we'll draw that line over. So why is the answer 56? Well, this is 50 milliliters. 1, 2, 3, 4, 5, 6. That's 56 milliliters at the bottom of the meniscus. It's not 60. It's not 59 where the top is, right? It's at the bottom, the base. Let's take a look at another one. So if we have a graduated cylinder that is in smaller units, then what we'll see is that we actually have to use the decimal system. So between 4 and 5, the bottom of the meniscus, we count up 1, 2, 3, and because this is between whole numbers, it's going to be a decimal, 4.3 milliliters. Okay, so you may need to be familiar with how to use those decimals. But again, it's the bottom of the meniscus. It's the one closest to the bottom. We'll try to be as accurate as we can. So why learn about mass and density? Why do we even care? Especially when we've been learning about how to identify minerals. Well, it all has to do with this term called density. And density is going to keep coming up in this class over and over again. So it's really important that you know what it is. So density is how much mass is contained in a given volume. So hopefully some of you are starting to connect the pieces. Oh, he went over mass, he went over volume. It was all to get to density. And I'll tell you why in a second, but first let's just understand this equation. So the equation is that density equals mass over volume. I know I said we're not doing a ton of math in this class, but this is one equation you have to know. Okay? Important. And we will learn how to do a couple of conversions with this, so stay tuned for that. Probably not in this lecture, but in the future. You have to know that density is how much mass is in a given volume. In other words, I like to say how much stuff is in a given space. This is the non-technical term. So we can go through some practical examples. Like, for example, if I gave you a beach ball, okay, and I'm not even going to try to draw it, but just think about it, what a beach ball looks like, and then I give you a shot put. Which one is more dense? Obviously, it would be the shot put, right? Because not only do you just inherently know the shot put is going to be much heavier, so it has much more mass, but that shot put takes up a lot less space. So there's more mass in that given space. So that means the shot put is going to be extremely dense compared to the volleyball, which is filled up with mostly empty space because it's filled up with a gas. Okay, and if you remember, gases, the molecules are spread out really far. So that's actually another part you need to know. Gases are the least dense. So if we're talking about how dense something is, gases are less dense than liquids, which are less dense than solids. Now, I will say there is one molecule we'll talk about later on where this actually does get flipped upside down a little bit, but don't worry about that for now. So the next question is, so if we know that mass is in grams, and we know that volume is in either milliliters or centimeters cubed, then what are going to be the units for mass over volume? Well, you probably saw this down here. Grams per milliliter or grams per centimeters cubed. So when you see these units, you should think density. So why is density so important? I kind of want you to think about this for a second. Why would density be important to us? And again, why is it so important to us when we're talking about identifying things like minerals? Well, let's consider 1 kilogram of iron versus 1 kilogram of cotton. Obviously, 1 kilogram of iron is going to be much smaller than 1 kilogram of cotton, which is going to take up a lot more space. Do you think it would be pretty easy to tell the difference between something? Do you think it would be pretty easy to tell the difference between the iron and the cotton based on their densities? Yes, because iron has a much higher density, whereas cotton has a much lower density. So why is this so important? Well, it turns out that every element has its own unique density. So how can that help us? Well, remember, if we're dealing with minerals, they're just chemical compounds repeated over and over again. So that means that identifying minerals and rocks can become much easier if you have, because it's very rare for two types of minerals to have the exact same density, right? So, if we have known densities, which we can look up online, then we can more easily identify the minerals or the unknown objects, and you will be doing just that. So you can have, and just so you know, you can have a mineral with the same volume, right? So I can take two rocks that have the same volume, they take up the same amount of space, but they're still made up of different minerals, right? And you could take a rock that is pretty small that has the same mass as a rock that is a lot bigger if just depending on the densities. So again, not to confuse you anymore, but basically we use density to further identify just anything in the physical world because it's so unique. And you guys will be getting practice with this when we get back next week, so prepare for that. All right, well, that's actually it for my lecture today. It was a little bit longer, but these were some important concepts, and hopefully we'll have some time in class today to go over some of the confusion. I know when math gets involved, some students kind of get a little bit worried, but we'll try to keep it light. But density is going to come back again and again, so we got to make sure we understand it. But anyway, all right, this is the end.